This is Module 6. In this video, we're going to look at the theory-based approach for categorical data, and then we're going to do example 5. So far in the course, we've approached hypothesis testing using simulation. In some situations, it's possible for us to use a theoretical mathematical approach to answering the same questions that we've been answering this semester. To use a theory-based approach, we do have to meet some validity conditions. So, as this reads, when the sample of categorical data has at least 10 successes and 10 failures, then we're allowed to use a theoretical normal distribution to model our distribution of sample statistics. In that situation, instead of using a simulation, we're going to be able to draw that normal curve and know that that normal distribution is centered at pi, just like it was with the simulation. And this formula will give us the standard deviation of that distribution of sample statistics. This formula is the square root of pi times 1 minus pi over n. It's called the standard error. It's the standard deviation of the null distribution. It's the standard deviation of the distribution of sample statistics. It's called the standard error. So we can then, of course, use the p-value or the z-score to get our strength of evidence. We're only allowed to use this theory-based approach with categorical data when we have met those validity conditions. That is, that we have at least 10 successes and 10 failures in our sample. And when we do use this theory-based approach, you're going to find that the distribution we create and the answers the conclusions we draw at the end will be the same as when we use a simulation-based approach. Let's take a look at an example. In example 5, it asks, do children prefer candy more or do they prefer toys more for Halloween? We test households in 5 Connecticut neighborhoods offering children 2 plates, one that has candy, one that has toys. They sampled 283 children who made the choice. And it turns out that 148 of the children took the candy and 1,135 children took the toy. So first it asks us to go ahead and write the null and alternative hypothesis. The null and alternative hypothesis are as follows. The null hypothesis is that pi is equal to 0.5, meaning that children pick candy or the toy randomly. They pick candy 50% of the time in the long run, or you might have written that as they pick the toy 50% of the time in the long run. The alternative hypothesis is that pi is not 50%, pi is not 0.5, so children are not picking randomly, they're picking one more often than the other, or the proportion of time they pick candy in the long run is not 50%. It asks to then use an applet to conduct a simulation and identify the standard deviation of the null distribution from that simulation. So this is just review. I'm opening up the Rossmann-Fanz applet and I'm putting in 0.5 here for probability of heads, since that is the value we're hypothesizing from the null hypothesis. The number of tosses is 283. I'm going to do 1,000 repetitions and I'm going to count samples like 148 and more extreme. This is a two-sided test, so I click the two-sided button here, and it'll count samples like 148 and higher. Then it goes to the other side of the distribution and goes the equal distance away from the middle, which is 135 and lower. So I get a p-value of 0.46. It does ask me to go ahead and identify the standard deviation of this distribution as well. I'm going to copy it both in terms of the number of heads picture, which I've copied and pasted here. And then I'll also switch it to proportion of heads and make sure that I also get a picture of that. So we see when we're on number of heads, it's centered at 50% of the 283, so it's centered at about 141.5. When we're on proportion of heads, it's centered at about 0.5. It says the mean is 0.499. When we're on number of heads, the standard deviation was 8.3 approximately, and when we're on proportion of heads, the standard deviation is about 0.029. Part C asks to explain why we can use a theory-based approach. We're allowed to use a theory-based approach because we have met the validity conditions. We have more than 10 successes and more than 10 failures. In this case, success is defined as picking candy, and a failure is defined as picking toy. It's told us in the problem that we had 148 successes, 148 times they picked candy, and it told us in the problem, going back up to it, oh, that's a typo. Typo! Notice it said 1,135 took a toy. That should be 135. Sorry about that. 135 failures, because 135 took a toy. Since we've had more than 10 successes and more than 10 failures, we have met the validity conditions and we're allowed to use a theory-based approach. Part D asked us to use the appropriate formula to find the standard error of the distribution of sample statistics. Standard error. Standard error is the standard deviation of the distribution of sample statistics. Standard error is the standard deviation of the null distribution. The formula for standard error is square root of pi times 1 minus pi over n. The pi from our null hypothesis was 0.5, so I plugged that into the formula. And n is the sample size, and the sample size in this problem, remember, was 283. Now, if you have a regular calculator, you could go ahead and plug that all in at this point. I just want to point out here for the online course, if you don't have a nice calculator to do this calculation, I want to recommend that you try Desmos.com. Here's the website, Desmos.com. When you go to Desmos.com, click on the scientific calculator. It's got a nice little calculator here. It's got this little square root button. You would hit square root. And then over here, there's this little fraction button, and it puts the fraction right there underneath your radical. And then you can just basically type it in the way that you see it on your paper. So I'm doing a 0.5 parentheses 1 minus 0.5, and then I click my cursor into the denominator and type the 283. And then when you press enter, it gives you your answer, 0.0297, etc. So 0.0297 is what I got for the answer there. All right, and it does ask us to go ahead and compare that back. Now notice, this calculation is involving the proportion of successes. So I should be comparing this back in my simulation standard deviation to the one involving proportions. The standard deviation from my simulation was 0.029, so it's very accurate. Part E says, calculate the value of the standardized statistic. Give the correct symbol for the standardized statistic. So remember, a standardized statistic is telling us how many standard deviations that our observed statistic is from the mean of the null. So in this case, it's a z-score. Z-score is calculated by taking our statistic minus the mean of the null divided by the standard deviation of the null. So our z-score, we're going to take our statistic, which was 0.523, minus the mean of the null distribution, which is 0.5, divided by the standard deviation of the null distribution, which we can take from here. I'm just going to write that as 0.03. Just rounding that a little bit. And I calculate that out. In the numerator, you'll have 0.023. We're dividing that by 0.03. On my calculator, I'm just going to do a 0.023 divided by 0.03. I'm getting 0.77 approximately. So my z-score is 0.77. Do we make the same conclusion with the theory-based approach that we would with the simulation-based approach? So notice I used a theory-based approach here to get that z-score. I got a null hypothesis value for the pi was 0.5. My standard deviation of the null came from my calculation here from the theory-based approach formula. And I would make a conclusion that since my z-score is pretty small, that the null hypothesis is plausible. Similarly, when we did our simulation, we got a big p-value, a p-value of 0.46, which also leads us to conclude that the null is plausible. In context, That means that it's plausible that the kids are just picking randomly between candy and toy in the long run. The reason that the simulation approach and the theory-based approach came to the same conclusion in the end is that we met the validity conditions. And when you meet the validity conditions, your theory-based approach and your simulation approach should come to the same conclusion.